Earth Science. This course covers a large number of topics that are concentrated into four main areas of study: geology, oceanography, meteorology, and astronomy. Objectives: define Earth science and explain how it relates to the sciences of geology, meteorology, oceanography, and astronomy. Describe specific characteristics of Earth, such as its shape, size, and subdivisions. Differentiate between igneous, sedimentary, and metamorphic rocks. Explain the difference between renewable and non-renewable sources. Define earthquake and explain how earthquakes are measured and predicted. Identify the various types of volcanoes and explain where they form. Define climate and explain the characteristics of the different climate zones. Explain the movement of the planets in the solar system. Earth Science. The branch of science dealing with the physical constitution of the Earth and its atmosphere. Geology. The science that deals with the Earth's physical structure and substance, its history, and the processes that act on it. Oceanography. The branch of science that deals with the physical and biological properties and phenomena of the sea. Meteorology. The branch of science concerned with the processes and phenomena of the atmosphere, especially as a means of forecasting the weather. Astronomy. The branch of science that deals with celestial objects, space, and the physical universe as a whole. Earth science is the study of our planet's physical characteristics, from earthquakes to raindrops and floods to fossils. It contains many branches, such as geology and oceanography, the study of the world's oceans. Earth is the fifth largest of the planets in the solar system, smaller than the four gas giants, Jupiter, Saturn, Uranus, and Neptune, but larger than the three other rocky planets, Mercury, Mars, and Venus. Earth has a diameter of roughly 8,000 miles, or 13,000 kilometers, and is round because gravity pulls matter into a ball, although it is not perfectly round, instead being more of an oblate spheroid, whose spin causes it to be squashed at its poles and swollen at the equator. Roughly 71% of Earth's surface is covered by water, most of it in the oceans. About a fifth of Earth's atmosphere is made up of oxygen, produced by plants. While scientists have been studying our planet for centuries, much has been learned in recent decades by studying pictures of Earth from space. Earth spins on an imaginary line called an axis that runs from the North Pole to the South Pole, while also orbiting the Sun. It takes Earth 23.439 hours to complete a rotation on its axis, and roughly 365.26 days to complete an orbit around the Sun. Earth's atmosphere is roughly 78% nitrogen, 21% oxygen, with trace amounts of water, argon, carbon dioxide, and other gases. The lowest layer of the atmosphere is known as the troposphere, which is constantly in motion, causing the weather. Sunlight heats the planet's surface, causing warm air to rise. This air ultimately expands and cools as air pressure decreases, and because this cool air is denser than its surroundings, it then sinks, only to get warmed by the Earth once again. Above the troposphere, some 30 miles, or 48 kilometers, above the Earth's surface, is the stratosphere. The still air of the stratosphere contains the ozone layer, which was created when ultraviolet light caused trios of oxygen atoms to bind together into ozone molecules. Ozone prevents most of the sun's harmful ultraviolet radiation from reaching Earth's surface. Extrusive igneous rocks cool and solidify quicker than intrusive igneous rocks. They are formed by the cooling of molten magma on the Earth's surface. The magma, which is brought to the surface through fissures or volcanic eruptions, solidifies at a faster rate. Sedimentary rocks are types of rock that are formed by the deposition and subsequent cementation of that material at the Earth's surface and within bodies of water. Sedimentation is the collective name for processes that cause mineral and or organic particles, detritus, to settle in place. A metamorphic rock is a result of a transformation of a pre-existing rock. The original rock is subjected to very high heat and pressure, which cause obvious physical and or chemical changes. Examples of these rock types include marble, slate, gneiss, and schist. A renewable resource is a resource which can be used repeatedly because it is replaced naturally. Examples are oxygen, fresh water, solar energy, timber, and biomass. Renewable resources may include goods or commodities such as wood, paper, and leather because their sources are renewable. A non-renewable resource is a resource of economic value that cannot be readily replaced by natural means on a level equal to its consumption. Most fossil fuels, such as oil, natural gas, and coal, are considered non-renewable resources in that their use is not sustainable because their formation takes billions of years. The term non-renewable resource also refers to minerals and metals from the earth, such as gold, silver, and iron, which are similarly formed as a long-term result of geological processes such as plate tectonics. Earthquake. A sudden and violent shaking of the ground, sometimes causing great destruction, as a result of movements within the Earth's crust or volcanic action. The Richter scale is used to measure earthquakes. The Richter magnitude scale was developed in 1935 by Charles F. Richter of the California Institute of Technology as a mathematical device to compare the size of earthquakes. The magnitude of an earthquake is determined from the logarithm of the amplitude of waves recorded by seismographs. Earthquakes with a magnitude of about 2.0 or less are usually called microearthquakes. They are not commonly felt by people and are generally recorded only on local seismographs. Earthquake. Earthquakes are not as easy to predict as volcanic eruptions. However, there are still some ways of monitoring the chances of an earthquake. Laser beams can be used to detect plate movement. A seismometer is used to pick up the vibrations in the Earth's crust. Radon gas escapes from cracks in the Earth's crust. Levels of radon gas can be monitored. A sudden increase may suggest an earthquake. A volcano is an opening in the Earth's surface where molten rock can escape from underneath. The Earth's surface is made up of tectonic plates, which are spreading apart, crunching into each other, or sliding beside one another. Volcanoes are typically found at the fault lines between these plates. There can be active volcanoes, which are currently or have recently erupted. There are also dormant volcanoes, which haven't erupted recently, and extinct volcanoes, which will never erupt again. There are 4 major types of volcanoes. Cinder cone volcanoes. These are the simplest type of volcano. They occur when particles and blobs of lava are ejected from a volcanic vent. The lava is blown violently into the air and the pieces rain down around the vent. Over time, this builds up a circular or oval-shaped cone with a bowl-shaped crater at the top. Cinder cone volcanoes rarely grow larger than about 1,000 feet above their surroundings. Composite volcanoes. Composite volcanoes, or stratovolcanoes, make up some of the world's most memorable mountains. Mount Rainier, Mount Fuji, and Mount Cotopaxi, for example. These volcanoes have a conduit system inside them that channels magma from deep within the earth to the surface. They can have clusters of vents, with lava breaking through walls or issuing from fissures on the sides of the mountain. With all this material coming out, they can grow thousands of meters tall. As we've seen with the famous Mount St. Helens, composite volcanoes can explode violently. Shield volcanoes. These are large, broad volcanoes that look like shields from above, hence the name. The lava that pours out of shield volcanoes is thin, so it can travel for great distances down the shallow slopes of the volcano. These volcanoes build up slowly over time, with hundreds of eruptions, creating many layers. They're not likely to explode catastrophically. Perhaps the best known shield volcanoes are the ones that make up the Hawaiian Islands, especially Mauna Loa and Mauna Kea. Lava domes. Volcanic or lava domes are created by small masses of lava which are too viscous or thick to flow very far. Unlike shield volcanoes, with low viscosity lava, the magma from volcanic domes just pile up over and around the vent. The dome grows by expansion of the lava within, and the mountain forms from material spilling off the sides of the growing dome. Lava domes can explode violently, releasing a huge amount of hot rock and ash. Climate. The weather conditions prevailing in an area in general, or over a long period. A region with particular prevailing weather conditions. The three major climate zones on the Earth are the polar, temperate, and tropical zones. Temperatures in these three climate zones are determined mainly by the location or latitude of the zone. Polar has the coldest, with temperatures almost always below freezing. Temperate contains most of the Earth's land masses, with more moderate temperatures and rainfall year-round. Tropical zones has the warmest average temperatures and gets the most rain. All 8 planets in the solar system orbit the Sun in the direction that the Sun is rotating, which is counterclockwise when viewed from above the Sun's north pole. 6 of the planets also rotate about their axis in this same direction. The exceptions, the planets with retrograde rotation, are Venus and Uranus. Prograde rotation means the direction of rotation is same as that of the Sun, the central hub of our system, which is in the counterclockwise direction when viewed from the North Pole. Retrograde rotation means the direction of rotation is opposite to that of the Sun, so clockwise rotation.